All right, today, section 5.6, a little bit shorter lesson today because it's just a formula, quadratic formula you can use to solve these. So our purpose statement for your paper is explain and describe how to solve quadratic equations using the quadratic formula. And our vocab for today is the quadratic formula and the discriminant. So far in this chapter, we worked with transformations, then we did solving equations by graphing, then we did them by factoring, and then we did them by completing the square. And so we're going to learn a final method today for solving quadratics, and that is using the quadratic formula. So the quadratic formula, if it's in the form ax squared plus bx plus c equals 0, if it's not, you need to get it in this form. Then the solutions or roots, remember the different solutions could be zeros, the zeros are roots. Remember we can use all of those terms solutions. Zeros are the real numbers and roots are the imaginary solutions. It's found by using the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the most common mistake I see people make on this is the 2a, it divides the whole thing. A lot of people just do it with the radical part, but you have to simplify this first. So if we just take as an example 3x squared plus 7x minus 5 equals 0. The first thing I would advise that you do is determine what a, b, and c are. So in this case, a is 3, b is 7, and c equals negative 5. And then we're going to simply plug it into the formula. So now, another common mistake, it says negative b. That means the opposite of what b is. So most people are okay, but sometimes they see it like a negative 7 and they just put a negative number in there. But it should be the opposite of. So since it's 7, it would be negative 7. If it was a negative 7, it would be positive 7. And then plus or minus the square root of b squared, so 7 squared minus 4 times 3 times the negative 5. And then the whole thing divided by 2 times 3. Now, if you remember at the beginning of the year, we talked about, a lot of you use, please excuse my dear Aunt Sally for order of operations, or PEMDAS, and you talked about parentheses. Well, remember, in Algebra 2, we have more than just parentheses and brackets as symbols of inclusion. So I said use symbols of inclusion because this fraction bar tells us to simplify the top and the bottom separately. The square root is also a symbol of inclusion. It says do what's in here first before you add the 7. So what we're going to do is start inside the square root. And so if I start in there, the first part stays the same, plus or minus 7 squared. So that would be 49. And then 4 times 3 is 12, and 12 times 5 is 60, and 2 negatives give me a positive. So plus, plus 60. And then I can simplify the bottom. 2 times 3 is 6. All right, so now we simplify still what's inside there. So that would be 49 plus 60. So we get 7 plus or minus the square root of 109 divided by 6. Now, the last thing you want to do is make sure, are there any perfect squares in 109? And there's not any perfect squares that go into that. So you want to check and see, like, does 4, 9, 16, 25, any perfect squares go into that allow me to simplify that problem. So we would be done in this case. We'd have two answers, negative 7 plus the square root of 109 divided by 6, and negative 7 minus the square root of 109 divided by 6. And you can just leave your answer that way. The book might write two answers. They might do this. But as you can, excuse me. So they may show it that way, but it's fine just to leave it like this. All right? Just remember, quadratic, we're going to have two solutions. One is negative 7 plus that, and the other one is negative 7 minus the square root of 109. All right, so that's what you're going to be doing Now, you will have to memorize the quadratic formula. So you're going to have to memorize this for the test. I'm giving extra credit, 20 points, and you can do it by yourself or with a partner if you sing the quadratic formula, and there's different examples of that. If you go to this YouTube channel, you can see a 5-year-old girl that does it to Pop Goes the Weasel. The other one's a different website for another activity. But if you'd like to see an example, you can go online and there's plenty of examples. So you won't be able to read it, but you'll have to sing it. All right, so example number 1 that you're going to do on your worksheet. 4x equals 5x squared plus 12. This one kind of incorporates everything that you could see on using the quadratic formula to factor this. So you have your choice. I'm going to move the 4x to the other side by subtracting 4x. And so we get, when we do that, 0 equals 5x squared minus 4x plus 12. Right? So our A is 5, our B is negative 4, and our C is positive 12. Now you could have moved this information to the other side. Then you would have had negative 5x squared plus 4x minus 12 equals 0. And so in this case your A would be negative 5, your B would be positive 4, and your C would be negative 12. So they're just opposites. You'll get the same answer either way. It doesn't make any difference. Some people like moving it to the left. I moved it to the right because I only had to move one number. And I like having the A positive, but it won't make any difference. So now using the quadratic formula, so it's negative B. So we do the opposite of 5, or negative 4, so that would be 4, plus or minus the square root of negative 4 squared minus 4 times 5 times 12, all over 2 times 5. So if we start again inside the square root, we get 4 plus or minus negative 4 squared is positive 16. And then we have to go 4 times 5 is 20, times 12 is 240, so minus 240 all over 10. So now we have to simplify what's in there. 4 plus or minus the square root of negative 224 all over 10. So a couple things in this. Remember, if we have a negative sign in, that's easy to take care of. We just bring an I out front for the square root of negative 1. But also remember, we're going to have to simplify radicals. So we need to look for perfect squares that go into 224. So again, there's lots of ways you can do that. You can use the factor tree and go 2 times 112. And let's say 2 times 56. That's 8 times 7. 8 would be 2 times 4. And then we have 2 times 2. And so now we have a pair of 2's and another pair of 2's. So out of this we're going to get a 2, because we're taking the square root, and out of this we get a 2. So we have 2 times 2 out front. And inside we have to leave the ones we don't have pairs for, which are 2 and 7. So we get 4 plus or minus. So we're bringing this 4 out front. And inside, we still have the I, and then we have what's left inside, the 2 times 7, which is 14 over 10. Now, some of you like doing the factor tree. Others of you can just go through the perfect squares and find out which one goes in it. So like, if I was doing this, I could find that 16 times 14, I could do it that way, and then the square root of 16 is 4. And so that 4 then comes out front. And I can't take the square, there's no perfect squares in 14. And so that stays inside. Most of your numbers won't be that big, but you just have to go through the process, whether you use the factor tree, how however you go through, you can just try the perfect squares and divide them into the 224 till you find one that works. It doesn't make any difference as long as you simplify it. When you get to hit this point, we're done except if a number goes into all the numbers that are outside. It doesn't make any difference inside, just the numbers outside. So in this case, 4, 4, and 10, 2 goes into all of those. And so I just divide everything by 2 to simplify it. Again, I don't take 2 into the square root of 14. And so this would give me my 2 answers. So it's a little bit of work, but it's simply plugging the numbers in, going through, and simplifying it. So that's the main part of the assignment. The other thing that we're going to work with on this assignment is the discriminant. And the discriminant is the part of the quadratic formula you can use to determine the number of real roots of a quadratic. Okay? And the discriminant is b squared minus 4ac. Well, if we go to our formula, that's that part right there. The reason this is called the discriminant, we're going to be able to determine what types of solutions we have. Not what they are by the discriminant, but what types. So by looking at this, what happens is, if this is a positive number, we can take the square root of positive numbers. We're going to get negative b plus whatever that number is, divided by 2a. And you're going to get negative b minus whatever that is. So you get 2 different answers when you do that. If b squared minus 4ac is equal to 0, well, the square root of 0 is 0, and negative b plus 0 is the same as negative b minus 0. So you're still going to get a real number solution, but you're only going to get 1. It's called a double root, because you still have 2 answers, it's just the same one, because plus 0 gave us the same as minus 0. And then if b squared minus 4ac is less than 0, well, that means it's a negative number. So we're going to get an imaginary number solution, and we're going to still have 2, so we'll get 2 complex numbers. So our notes, if b squared minus 4ac is greater than 0, then we have 2 distinct real solutions. If b squared minus 4ac is equal to 0, then there's 1 distinct real solution. And if b squared minus 4ac is less than 0, then we have 2 distinct complex solutions because they'd be imaginary numbers. So what they're going to do on this is they're going to ask you to take a problem, and this is example 2 for your sheet, and just find out what types of roots we have. We don't have to find the solutions. We just have to find out, is it 2 distinct real solutions, 1 distinct real solution, or 2 distinct complex solutions. And so all we do is we look at the b squared minus 4ac. So we plug in b, which is negative 12, minus 4 times a negative 8 times a negative 3. Again, it may help to write down what those are. A is negative 8, b is negative 12, and c is negative 3. So negative 12 squared would be 144. And then we have 4 times 8, which is 32, times 3, which is 96. And I have 3 negatives, so it's negative. Now, I really don't need to go any further. And else they ask you to tell what the value is, then you would have to subtract and get your 48. But I can tell right here that the positive is bigger than what I'm subtracting, so I know it's a positive number. So I know my answer is 2 distinct real roots. If this number would have been bigger than this number, then I would have known, since I'm subtracting it, that it is 2 distinct complex solutions. If they're the same, then it would be 1 distinct real solution. The thing you have to be careful of is keeping track of your negative signs, so you know that if this is minus or plus. Let's do one more example of this. Let's take 5x squared minus 3x plus 7. Okay? So b squared, that would be negative 3. So a is 5, b is negative 3, c is 7, so that would be negative 3 squared, so 9, minus 4 times 5 times 7. Now really, I should be able to stop right here because I already know that this number is going to be a positive number. 4 times 5 is 20, times 7 is 140, so it's going to be 9 minus 140. But as soon as I see it's minus, and I know this is going to be bigger than 9, I know that it's two distinct complex solutions. So that's what you're going to be doing in this assignment today. Hopefully you'll find it fairly easy to do by just plugging in the numbers. Your assignment is page 361, numbers 19 to 53. Remember, you can get 20 extra credit points for homework by singing to the class the Quadratic Formula song, and you can do that by yourself or in pairs. So good luck with the assignment.